Can you imagine willingly swallowing a tube with a window to observe your own digestion? In the 1820s, Dr. William Beaumont did just that. After an accident left a patient with a permanent opening in his stomach, Beaumont seized the opportunity to study digestion firsthand. Over several years, he conducted experiments by inserting foods tied to strings into the stomach, observing digestion, and documenting his findings. His work, while unorthodox, provided unprecedented insights into the digestive process, shaping our understanding of human biology. Beaumont's self-experimentation reminds us of the lengths some go to for scientific discovery. Edward Jenner's story is legendary. In 1796, faced with the devastating impact of smallpox, Jenner took a bold step. He inoculated a young boy with cowpox, a milder disease, and then exposed him to smallpox, proving that the prior infection provided immunity. This experiment, although controversial and risky by today's standards, laid the foundation for the development of vaccines. Jenner's work not only exemplified self-experimentation, but also marked a pivotal moment in medical history, revolutionizing our approach to disease prevention. Wim Hof, famously known as the Iceman, has pushed the limits of what we thought possible for the human body. Through self-experimentation, Hof developed a technique involving cold exposure, breathing exercises, and meditation that he claims can control the immune system. Scientific studies on Hof and his followers have shown remarkable results, such as the ability to influence the autonomic nervous system and the immune response. Hof's methods, while still under investigation, have garnered global attention, showing how personal testing can challenge and expand our understanding of human physiology. In a bid to enhance human night vision, biochemist Gabriel Licina embarked on a daring self-experiment. He used a solution derived from chlorophyll to temporarily improve his night vision. Remarkably, his experiment was successful, with Licina reportedly able to identify shapes and symbols in near darkness. This groundbreaking experiment, though still in its nascent stage, hints at the potential of biohacking in augmenting human capabilities. It stands as a testament to the boldness and creativity inherent in self-experimentation. Albert Hofmann, a Swiss chemist, unintentionally discovered the psychedelic effects of LSD in 1943. After accidentally absorbing a small amount of the substance, he experienced extraordinary visual distortions and mood alterations. Curious, he later took a deliberate dose, marking the first intentional LSD trip. Hofmann's self-experimentation opened the door to a new realm of psychiatric research and profoundly influenced cultural and artistic movements. His experience highlights the serendipitous nature of scientific discovery and the profound impact of self-experimentation. Dr. Yoshinori Osumi, a Japanese cell biologist, made groundbreaking discoveries about autophagy, the process by which cells recycle their content. Intrigued by the potential health benefits of fasting, he conducted extensive research, including self-experimentation with various fasting regimes. His work, which won him the Nobel Prize in Physiology or Medicine in 2016, not only deepened our understanding of cellular processes, but also sparked a global interest in fasting as a health practice. Osumi's dedication shows how self-experimentation can lead to major scientific breakthroughs and influence public health practices. Werner Forssmann, a German medical student in the 1920s, conducted a risky self-experiment that revolutionized cardiology. He inserted a catheter into his own heart, a procedure considered outrageous at the time. Despite the dangers, his successful experiment laid the foundation for cardiac catheterization, a now common and life-saving medical procedure. Forssmann's daring act exemplifies the courage and determination often found in self-experimenters, whose personal sacrifices can lead to significant medical advancements. In 1984, Dr. Daniel Zaguri, a French immunologist, took an extraordinary step in the fight against HIV/AIDS. He injected himself with a potential vaccine containing a small, inactive part of the virus. His self-experimentation, driven by the urgent need for a vaccine during the height of the AIDS crisis, was a bold and controversial move. Although the vaccine ultimately did not succeed, Zaguri's efforts underscored the urgency and challenges in combating deadly diseases and the lengths scientists will go to find solutions. Dr. Barry Marshall, an Australian physician, famously swallowed a culture of Helicobacter pylori in 1984 to prove its role in causing peptic ulcers, a theory widely dismissed at the time. His resulting illness, followed by a cure using antibiotics, dramatically shifted medical understanding and treatment of stomach ulcers. Marshall's willingness to use himself as a test subject highlights the extraordinary measures some researchers will take to validate their theories, fundamentally altering medical paradigms in the process. Randy Gardner holds a record that is both astonishing and cautionary. In 1964, as a high school student, he stayed awake for 264 consecutive hours, about 11 days, to study the effects of sleep deprivation. His experiment, monitored by a Stanford sleep researcher, revealed significant cognitive and emotional changes, contributing valuable data to sleep science. Gardner's experience underlines the human body's limits and the potential risks of self-experimentation, serving as a reminder of the fine line between curiosity and safety. Thanks for watching. If you enjoyed these incredible facts, remember to like this video and subscribe to SciPulsar for more fascinating content. Until next time, stay curious and see you soon.